Every guest I have on this show demonstrates how far we've come in terms of innovation and technology in the auto industry, where boundaries are being pushed that years ago seemed impossible to do. As the world evolves at a rapid pace, so must technology, and this is a sentiment that I know today's guests would wholeheartedly agree with. Hello, and welcome to the second part of my interview with Rob Gray. If you listened to part one, you already know Rob is the technical director at Red Bull Advanced Technologies, a high-performance engineering and sister company of Red Bull Racing. Red Bull Advanced Technologies works within a range of industries on projects that push the boundaries of technology and innovation. In part one of this interview, Rob and I discuss his past experience in Formula One, Arbat's first hypercar project, as well as the company's recent work designing an America's Cup boat. In this part two episode, we learn a bit more about other projects Rob has that include a BMC project to revolutionize bike design and building the world's first flying skate park. We also discuss the hot topic of sustainability within racing and how he thinks F1 will change as it moves to carbon neutrality. And we finish off with Rob's vision for the future of Formula One. I'm Ed Bernardin, and welcome to part two with Rob Gray.
You're a cyclist.
Yes.
That's a hobby you enjoy. And you've now partnered with BMC to revolutionize bike design. It's called Speed Machine, Team Machine R, are the names of these bikes. What are the key performance parameters or the features that make a good racing bike? Because you can speak from experience.
Yeah, I mean, it's so I think talking really about the Team Machine R, the key things were the weight, first of all, so getting it as light as possible, the aerodynamic drag, and then various stiffness and compliance targets to make it nice to ride. And so it's not overly complicated, but it's knowing where those different parameters need to sit. And so the aim with the Team Machine R was to end up with a bike that was both aerodynamically efficient and lightweight, so it could be a climbing bike. Because traditionally,
climbing bike like up the big hills
the big
that you
hills,
would have in the Tour de France or something like that.
So traditionally, manufacturers would have an aero-specific bike that was heavy for going on the flats, for time trials and that kind of thing. And then they'd have a climbing bike that wasn't very aerodynamic, but would be super lightweight for going up the hills. And so really the aim with Team Machine R was to combine the best of both of those worlds.
So how'd you do that?
Well, very much using the same processes that I keep talking about. So we started off on the aerodynamic side, thinking about doing some sensitivity studies, understanding how changing different aspects of the bike influence the drag. And then once we've got a sort of a baseline of shape that we thought was going to deliver, you then pass that over to the finite element analysis team within the structures team. And they analyse the bike to see whether we can see what laminate we need to put onto the bike, and then see what that weighs, and see whether we're hitting the stiffness and compliance targets that we're aiming for. You go back around the loop. So if you can't hit those targets, which is pretty unlikely to do first time around, you're then into what changes do we need to talk to the aero guys about to then come up with a slightly modified shape that's more structurally acceptable. And then you redo your laminate, go back through the loop and go around again.
So if I were to take the original BMC bike and the improved, better performing, would I be able to see a difference, or is it something I'd only be able to tell if I actually rode it?
I think it's
like, what would you see different?
I think the top tube shape's fairly distinctive. I think the sort of fork legs on the front of the bike, there's a decent gap between the fork legs, which is fairly unusual. So yeah, there's a few key differences that you can pick up.
Oh, the fork legs are wider apart.
Yes.
Did that surprise you that was better?
Yeah, initially.
No, why? One would think if you make the cross section, right, the view from the front wider, that would be bad for aerodynamics.
It's all about what happens to the flow behind the fork legs, though. So it's thinking about where the air goes when it's coming off the fork legs, rather than worrying about the actual influence of them themselves.
I believe that you've integrated the water bottle into the frame. Part of the frame is a water bottle.
It's not a structural part of the frame, but it's designed to be part of the bike. It's sort of fairly fed in.
Stefan Christ, is that how you pronounce his name? He was the head of R&D for BMC, and he said he described the collaboration as a two-way technology exchange. So what were the biggest things you learned from designing a bike that you didn't think you said, wow, I never would have thought that?
Well, I suppose two things spring to mind really. First of all, regulations, because the UCI, the Cycling Authority, they have a lot of regulations that you have to comply to, and that we had to make sure the bike was legal to use in the Tour de France and other races. And then coupled with that is the ISO test standard, so you have to make sure the bike's safe to sell. And then the other aspect, which some of the team learned about, it wasn't so much for me, but some of the guys really had to learn about the practicalities of cycling and simple things like where the water bottle goes and how easy access is, and it was a bit of a learning curve.
But I would imagine if you make a big bulky water bottle, that's not going to be good for aerodynamics,
Yeah,
right?
exactly.
Yeah. Now sometimes you get some really crazy projects. So I want to talk to you about one of those, which is the world's first flying skate park. So it's a 1.7 ton BMX bowl that you lifted up with this one of the world's largest balloons. And this was done in partnership with Chris Kyle, BMX rider.
Yeah.
And he said he wanted to conquer his fear of heights. So he's not afraid of a BMX bike when he's riding that around. So why not put it, 2,000 feet up in the air? That'll cure my fears. Where did the idea for this come from?
It came from Chris. I think he said I think I'm right in saying he said he was walking his dogs in the woods during COVID lockdown and daydreaming. And he just had this idea. He was like, well, wouldn't it be great if I could be up there doing my tricks? And so they came to us and told us what they wanted to do. And we were like, well, of course you do. Why wouldn't you? And then we got stuck in.
So tell us a little bit about this. I mean, the balloon is one of the world's largest balloons ever.
the balloon,
How do you get a skate park up in the air?
So the balloon was the biggest balloon in Europe, I think.
In Europe,
especially made for that application.
And it's a helium balloon, or
hot air balloon.
hot air balloon?
Yeah,
Okay.
Yeah, and then the skate bowl itself. So the challenge was that they built a plywood mock-up of the bowl that they wanted to use, because it's very sort of shaped and tailored to him. So
That's to fit in the carriage underneath. Right?
No, tailored so that he can do different tricks and different jumps on it. It's not just it's not a sort of simple shape. It's got quite a few different parts to it. And so they built this plywood mock-up, and I think it came in at like 10 or 12 tons. And the balloon had a limit of 3 tons to be able to actually take off. So they came to us and said, look, this is what we want to do. Can you make us a bowl that the balloon's going to lift? So that was when we then got.
So 2 tons instead of 3 tons, then basically.
No, 2 tons instead of 10 tons.
Oh, instead of 10?
Yeah.
Oh, wow, from 10
Yeah.
to 2.
And so we designed it in carbon. The other challenge was that it, and we did all the stress analysis to make sure it was strong enough. And the other challenge was that it needed to be, so landing was quite a worry, because obviously this thing's going to touch, the bowl was going to touch down before the balloon.
So it touches down. Are you afraid that the balloon would keep going or something?
Well, just more afraid that so normally the guy flying the balloon is in the basket.
Okay.
And he can see where the ground is, but he's got this thing dangling beneath him.
Okay.
Sort of, 30 feet. And so that's going to touch down first, and then the basket's going to follow. And just trying to make sure that you've still got a bowl after you've landed.
Because you have a balloon,
Yeah.
a basket, and then you have the BMX skate park underneath.
And one of the other things that really drove the design was the need that they wanted to be able to land in any farmer's field. But this bowl is quite big, so we ended up having to make the bowl in, I think, 21 sections, all of which were then bolted together, so that when they landed in some field, they could take the bowl apart and still get it out the 6-foot wide gate.
Well, those are the interesting design constraints.
Yeah.
Because that makes it challenging, right? Not only
Yeah.
does it have to be lightweight, 2 versus 10 tons, but you have to be able to disassemble it and assemble it quickly.
Exactly.
And all that kind of thing. So when you're working with a guy like Chris Kyle, are you ever in a situation where, oh, here comes somebody with this crazy idea. Now you have to figure out, is this really too crazy to ever do? Or maybe we could do that. I mean, how do you balance that when you have one of these projects? Do you ever turn anyone away?
No, never turn anyone away initially, at least. And we do get some fairly out there requests. But it's kind of the engineer's job to think of, well, how do we do this and make it have an acceptable level of risk and make it safe for the guys doing it. On the balloon side, so Chris wore a parachute.
Okay, that's good.
Yeah,
That's
so he had that ultimate safety net. But I mean, still, I think if you watch the video of what he actually did up there, it was absolutely
Well, he's
incredible.
lifting above. You
Yeah,
see him lifting up.
yeah.
He's doing flips and turns. And
Yeah. But no, so we rarely turn anyone away. Occasionally, we'll be asked to look at things where there's an idea, and you'll look at it and you'll say, well, we'll assess the feasibility of it, and you'll come back and say, well, actually, we've looked at it and we don't think it's doable. But it tends to more be from the kind of the physics of the problem rather than the safety side that something might not be feasible.
Interesting. Did it cure his fear of heights?
I'm not sure, actually. I'm not sure.
I mean, that was the goal, right?
Yeah, he seemed pretty comfortable.
Yeah, he was happy when he was up there. He sure looks happy in the video, that's for sure.
Yeah.
Got any other exciting projects you're thinking about? Or tell you what if you could do anything that's on that crazy side? Is there any project you got in your head that, man, I'd really love to find somebody out there that would want to sponsor this project?
Well, I mean, the one that springs to mind that we didn't do, which I'd have loved to have been involved in, was Felix Baumgartner when he jumped from the edge of space from the balloon. Because I mean, that for me was one of the best things Red Bull have ever done. You know, it was an absolutely inspirational project, but that's been done.
Yeah, and he was in space, right? Or on the borderline,
on the edge.
Yeah.
On the edge.
And I think jumped in a spacesuit. He actually did a parachute jump.
Yeah, so that was great. And then, you know, personally, I suppose there are some. I'm interested. I look at things like powerboat records, the transatlantic powerboat record, and I wonder whether there's something to do with new technology to fuel that, something like that, maybe. But
world's fastest Atlantic crossing, or
something like that. Yeah, that would be pretty cool. Maybe power it by hydrogen. So yeah, something like that.
We always hear about how an F1 car has so much downforce it could run upside down in a tunnel, but it's never been done. But like you said, sometimes you look at the physics of a problem, and the physics of that problem says that it could be done. It could be done. What would you have to do to the tunnel so that, and I assume the F1 car stays the same, or maybe not, but what would you have to do to the car, to the tunnel? And roughly, if someone's interested in doing this, what do you think it'd cost?
Well, I mean, we have looked at it in the past, and I think the biggest worry with the car is the engine going to be happy running upside down? Because you really don't want the engine to be cutting out when you're upside down. So in the past, we've thought about whether you go to an electric powertrain, because we've never really wanted to be pushing people to put engines on dynos upside down, and so that's a big job then, to put an electric drivetrain in the F1 car. And in terms of other changes to the car, well, it should all be feasible. I mean, it's a case of running it through the simulation, seeing how the loads look in the suspension, making sure you're within all of your load limits, and then it's the safety side of it, because how high is the tunnel you want to run on? Because you've got to think that, well, the driver is up there, upside down, on the roof of a tunnel.
Parachute's not going to help you there.
Parachute's not going to help you.
No.
But we've talked about catch netting. We've talked about all sorts of safety schemes to help. And the tunnel itself, well, really you want a pretty big tunnel.
Big in terms of the length?
Big diameter. Well,
diameter.
It needs to be a long tunnel as well. And then it's.
And why? Why do you need a big diameter?
I think because we're not totally sure about is how the curved track surface will influence the aerodynamics.
Oh, you're right. So the bigger it is, the more it approaches a flat track.
Yeah.
Oh, that's right, because one wheel would be on a curve this way. This is something you never see on a track, right? Because it'll tend to be sloped, off camber, or a bank turn, but you never have like a turn that's like a hill. Right, where one wheel's doing this, and the other one's doing the opposite.
Yeah, but also just if you think about even if it's sat in the bottom of the tunnel, and the car's in the sort of the dip.
Yeah.
Well, the diffuser's further off the ground, and the front wing's further off the ground than it would be on a normal track.
Right.
And so how does that influence it?
You might have to make a Formula One car that's curved.
But then is that cheating? Because it's supposed to be, does a Formula One car run on the roof of a tunnel?
These are the challenges, right, of trying to do something that's never been done before.
And cost, I don't know. I mean, I think when we talked about it before, it was sort of north of 5 million. So it's not a small project.
I could trade my RB17 in for this. Yeah. All right. Let's talk a little bit here on our final questions about Formula One and how sustainability is impacting Formula One. There's the push, of course, to be carbon neutral by 2030. So there's new rule changes coming in 2026, and that powertrain is almost 50-50 on the energy recovery electrical part versus the internal combustion engine. But then in 2030, 4 years later, which is the year where you're going to try and be carbon neutral, Formula One's going to try and be carbon neutral. What do you think is going to change on how they're powered? I mean, there's so many possibilities here. hybrid, battery, hydrogen in many different forms. What do you see? Where do you think it's going?
So I think the 2030 target is about more than just the car. So it's about the whole industry. Whether that be the shipping of parts to the track, the car itself, the factories, there's a whole load of different aspects.
Yeah, and in fact, it's less than 1%. I've seen studies that show that the actual cars on the track are less than 1% of the emissions.
And then the 2026 rules, the other aspect of that is that they have fully sustainable fuel. So either e-fuels or certain types of biofuel, I think, also qualify. And so the 2026 car is very good on the carbon neutrality front. So I'm not sure that we're going to see a wholesale change of engines or power systems for 2030, because that feels a bit soon. But then longer term, where will it go? It's really difficult to say. I mean, the e-fuels is a neat solution for Formula One that allows you to have a car that still sounds like the current cars sound, so still sounds good and has all the emotion whilst being carbon neutral. And other options at the moment don't seem to really deliver the same bang for buck. So I think it'd be very difficult to do an all battery powered F1 car at the moment.
And why is that?
Just because of the amount of space you need to store the batteries. And similarly with hydrogen. I mean, hydrogen looks like it's got applications in transport in the future, but actually packaging those hydrogen tanks into a Formula One car, it's going to look quite different from how a Formula One car currently looks. So I think it's going to depend on where the industry wants to go. So where the mainstream automotive manufacturers want to go, and then because that tends to drive where the racing follows.
You mentioned hydrogen because to use hydrogen in a combustion mode is really interesting, because if you're using it in a combustion mode, you get all that noise, and in that sense, it doesn't really change. It's not like an electric race car, which has more of a whine sound and the roar of the engine. But I guess one of the problems with the combustion of hydrogen in a vehicle is the size of the fuel tank. If you were to fit a hydrogen combustion engine into a Formula One car now, and were to take as much space as you could take for the fuel cell, how far could it go? How many laps could it run, do you think?
What, into an existing car?
Yeah, an existing car can't change the shape.
The problem is the tanks have to be very regular shapes. You can have pressure vessels. It needs to be either spherical or cylindrical.
Oh, right. It's not like a fuel tank for liquid fuel.
So it's not like the Formula One car fuel tank is sort of a very irregular shape. So I don't know. I think you'd struggle to get a hydrogen tank in there that was going to do any more than maybe 3 or 4 laps.
If you look at some of the tanks that you have, even for hydrogen as a gas, they look like a typical tank.
Exactly.
Right. A pressure vessel.
Yeah.
But as soon as you start making that pressure vessel a regular shape with sharp corners, those are the places where you get, as they say, you have a lot of stresses and things like that, where the cracks can form. So I guess it gets a little bit tricky there.
Yeah, I mean, I think the tanks are such high pressure for hydrogen. I mean, you're talking normally 700 bar. It's not really an option to go away from anything that is a tank shape.
Yeah. So in the short term, then, e-fuels, which are carbon neutral. You're still emitting carbon while you're running, but carbon neutral, because they're created.
Yeah.
They're created by extracting carbon from the air and combining it with hydrogen and all that. So that's 2025. You said
2026. Yeah.
2026, right?
Yeah.
The e-fuels will achieve that. So I guess we'll have to wait and see.
Yeah.
We have to wait and see, and it all comes down to the regulations, like you just said.
It does, yeah.
If one of the regulations becomes that the car cannot emit CO2 while racing, which is different than carbon neutral, then who knows? Who knows what will be there? So, like you said, it's not just about the car, but there's also the transport of the people, the equipment, all the things you need to run the paddock, right? From entertainment to taking care of the drivers, whatever it might be. That's where a lot of the emissions are coming from in the movement of all that equipment. So, and Formula One has been working on this now for a while, towards their goals for 2030. What has been learned? Has anything been learned, do you think, in the years that have passed by already, that you think can help in the commercial world in making things more sustainable?
Well, I think one of the big things Formula One did was switching to their remote broadcast, where they do a lot of the work on the TV production back in the UK rather than shipping all the people around the world. But I think you'd have to attribute some of that to COVID rather than any particular sport that's driven it, because it was COVID that pushed us to be a bit more efficient with how many people we sent around the world and got us also into the world of Zoom and other video conferencing. And then in terms of other lessons learned, I think it's really just a lot of it's just about being sort of fairly sensible. So, I think Formula One are looking at the calendar, trying to think if there's a more efficient route to take around the world rather than going backwards and forwards. It's those kind of things that I think can make a difference.
What do you think motorsport's going to be like in the year 2050?
2050.
Yeah. So who knows what the regulations might be, but certainly sustainability and no emissions. That'll probably be. It could be anything. How do you think it's going to go? What's going to happen between now and then?
I suppose first of all, look back. If you look back a similar time period.
Oh, that's a good way to do it.
Before
So it'll be
then,
what, 95 or
yeah,
something
like that. The cars are still pretty recognisable as cars, aren't they?
Yeah.
There's not like a wholesale change. I think you have to go further back to see that. It's still mid-engine carbon fibre chassis back then, so it's that's fairly interesting. But then thinking about where the cars will go, well, I'm on the Formula One side. I'm imagining probably more electrical. I'd be surprised if at some point front axle electrical recovery doesn't come into the mix. General motorsports wise, I think the rise of esports is probably the biggest thing that we're going to see change. It's a lot of there's a lot of news at the moment about how there's going to be new ladders into motorsport via the esports world, and I think that's a fairly sort of inevitable development, and it's a lower cost route into motorsport, and it's probably a more sustainable route in. So I think that's that'll be the biggest thing I think we'll see change.
I love how you thought about the problem. It shows how Red Bull Technologies thinks. Like, well, let's look back. So let's take that a step further then. If we take the next century, 2100, so that's 75 years into the future. If we go 75 years back into the 50s or 60s or 50s, say, that's right about when Formula One really was getting started. So we're at the midpoint from where Formula One started to the year 2100. So you raise a good point. A Formula One car in that first Formula One race at Silverstone had 4 wheels. It looked like
there was a lot more variety back then, and that was pre-aero as well. So it was before the aerodynamic rules came in.
Yeah.
So 2100, I don't know. It's a long way away. I kind of, you can get carried away and.
But you're advanced technology, so you're the right person to ask this to.
Get carried away and think, are we going to be doing Star Wars style pod racing, or what's it going to be? And it's just as deep as your imagination can be. I love the idea of something like that, but it also feels slightly fanciful. So maybe we'll be, and I think there's also a lot of heritage in the sport that we'll be trying to keep. So I guess I hope the cars will still be recognisable as cars. They'll be hugely efficient. The sustainability aspects will all have been sorted out. They'll still be noisy to keep the emotion in the sport, and we'll still be enjoying it.
It's interesting when you talk about some of those early cars, right? And now you've got Formula One drivers trying to drive a car as fast as they can. Obviously a lot of common skills to those drivers in the 50s, say, but they're also pressing buttons for DRS, and they got to worry about warming up the tires and on and on and on. And I suppose when you start adding all these technologies, the skill, there's going to be certain people that are going to be able to bring those skills out, but it's going to be a unique combination. Like you said, it might be, now they come up from karting and work their way through to eventually get to Formula One. Now esports might be a critical part of what that 2100 race driver is going to have to do. Who knows?
Yeah, I think it's likely.
Rob, thank you so much. You've really given us a great look into the Red Bull Technology Group. Another side of something different than what we're all familiar with, like I said, the Formula One team.